everyone, myself Hanasha. So today we are going to study the topic named gradient and directional derivative. So let us start with the definition of gradient. So the vector differential operator nabla is defined as del, or you can call it del also, del by del x of I cap plus del by del y of j cap plus del by del z of k cap. So the gradient of the scalar field phi is denoted by grade phi and is defined as gradient of phi is equals to del phi is equals to del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap. And this gradient is a vector quantity, right? So you just have to find the partial derivatives with respect to x, y and z and put in this formula. Okay, so now let us study few examples of gradient. So if phi is equals to x, y, z, this is a scalar field. We have to find the value of mod grade phi, that is magnitude of gradient at point 1 to minus 1. So firstly, let us write the formula of gradient of phi, right? So that is equals to del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap. Fine. Now you just have to put the partial derivatives over here. So let us put the answers of the partial derivative. If I want to evaluate with respect to x, we have to keep this y and z constant. So yz will remain as it is. Derivative of x is what? 1. Similarly, del phi by del y will be what? Xz, right? And lastly, del phi by del z will be what? Xy. Now you have to put this point 1, 2 and minus 1. So gradient of phi at point 1, 2 and minus 1. So our value of x is 1, y is 2, z is minus 1. So let us put this value. So here it will come minus 2 I cap plus, and here x is 1, z is what? Minus 1. So minus j cap plus x and y values are 1 and 2. So plus 2 k cap. So this is our answer of gradient. Now we have to find the magnitude of gradient of phi. So we have to just find the length. So it will be square root of minus 2 square plus minus 1 square plus 2 square. So it will be 4 plus 1 plus 4. Right? So answer will be what? Square root 9. So the magnitude is what? 3. Okay. So now let us go to the next example. If phi is equals to 3x square y minus y cube z square, then we have to find the gradient of phi at point 1, minus 2, minus 1. So let us again write the formula of gradient of phi. It is del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap. So now we have to write the answers of the derivatives with respect to x, y and z. So let us write the answer of del phi by del x. Here these two are constant, so here we have to evaluate only this quantity. So it will be 6xy, right? Now we have to evaluate with respect to y. So answer will be 3x square minus 3y square z square. Okay, and lastly we have to find partial derivative with respect to z. So here it will be minus 2y cube z. Okay, so now we have to put the values of the x, y, z. So x is 1, y is minus 2 and z is what? Minus 1. So let us put the values in this gradient of phi, that is 1 minus 2 minus 1. So this will be 6 into 1 into minus 2 I cap plus this will be equals to 3 into 1 square minus 3 into minus 2 square into minus 1 square j cap, right? And lastly it will be minus outside plus minus minus, so 2 into minus 2 whole cube into minus 1 k cap. Okay, so now let us simplify this. So it will be minus 12 I cap. Here it will be 3 and this will be minus whole square it is, so it will be 4. So 3 into 4, 12 and this will be plus 1. So 3 minus 12. So it will be minus 9 j cap, and this will be equals to, here this will be minus 8 into minus 1. It will be plus 8 into 2. So minus 16 k cap. So this is our answer of gradient of phi at 1, minus 2, minus 1. Okay. So now let us go to the next example. We have phi as log x square plus y square plus z square. We have to find gradient of phi at point 1, 0, minus 2. So again, let me write the formula of gradient of phi. It is del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap. So the derivative answer of log will be 1 upon x square plus y square plus z square. Now we have to evaluate with respect to x. So using chain rule, these two will be constant and derivative of x square will be 2x, right? Again, if I do the partial derivative with respect to y, answer will be 1 upon x square plus y square plus z square. Now this x and z will be constant, so derivative of y square will be 2y. And lastly, answer of the partial derivative with respect to z will be 2z upon x square plus y square plus z square. Okay. Now let us put the point, that is 1, 0, minus 2. So x is 1, y 0, z is minus 2. So if I put these values over here, answer will be 2 I cap upon 5, right? Because y is 0, so 1 square plus minus 2 square, it will be 5. Now if I put over here y is 0, so this whole term will go to 0, so I will write 0 j cap, and plus if I put over here minus 2, it will be minus 4 upon 5 j cap. Okay, so this is the answer of the gradient. Now let us solve one more example. We have to find the unit normal vector to the surface x cube plus y cube plus 3xyz is equals to 3 at the point 1, 2, minus 1. So first our phi of x, y, z is equals to x cube plus y cube plus 3xyz. Take this 3 on this side, minus 3. So this is our phi. Now we have to find the unit normal vector. So the formula of unit normal vector is n cap is equals to del phi upon length of del phi, that is gradient upon its magnitude. So let us firstly find the gradient of phi, right? So the formula is del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap. So now just find the derivatives with respect to x, y and z and write over here. So if I evaluate with respect to x, answer will be 3x square plus 3yz. Now solve the partial derivative with respect to y. So it will be 3y square plus 3xz, right? And lastly evaluate with respect to z. So it will be what? 3xy. Now we have to put the point as 1, 2 and minus 1. So if I put x as 1, this will be 3 and y as 2 and z as minus 1. So 3 minus 6, right? So it will be minus 3 I cap. Now put over here, so it will be 3 into 4, 12 minus 3. So plus 9 j cap, and lastly it will be 6 k cap. Okay, so this is the answer of the gradient. Now the unit normal vector formula is what? Gradient of phi upon length of gradient. So gradient is minus 3 I cap plus 9 j cap plus 6 k cap upon its magnitude. So upon 9 plus 81 plus 36. Okay. So final answer of n cap will be minus 3 I cap plus 9 j cap plus 6 k cap upon square root 126. Okay. So this is your answer of unit normal vector to the surface. Now let us go to the next example. Here you are given our vector r bar as x I cap plus y j cap plus z k cap. We have to show that gradient of log r is equals to 1 upon r into r cap, where r cap is a unit vector. So r cap is what? Unit vector. So I can write this as r bar upon mod r bar, right? That is vector upon its length. Now furthermore we are given our r bar as x I cap plus y j cap plus z k cap. So I can write this as r square is equals to x square plus y square plus z square, because our mod r is what? Square root of x plus y square plus z square. So taking square on both the sides we will get this. Now firstly what I will do is I will find partial derivative of this function with respect to x, y and z. So firstly do the derivative of this with respect to x. So it will be 2r del r by del x is equals to 2x. Therefore, your answer of del r by del x is what? X upon r. So, similar answer of del r by del y will be what? Y by r. And lastly, the answer of del r by del z will be what? Z by r. Okay. So, now let us find the gradient of log r. Firstly, the formula of the gradient is what? Del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap. Now our phi is what? Log r. So it will be del by del x of log r, right, plus del by del y of log r, right, plus del by del z of log r k cap. Just find the partial derivatives of log r. So this will be 1 upon r into what we have to put? Del r by del x I cap, because r is a function of x, y and z. Similarly here it will be 1 upon r del r by del y j cap, and here it will be 1 upon r del r by del z k cap. We know the answer of these three quantities, right? It is x by r, y by r and z by r. So we can write this as 1 upon r into x upon r I cap plus 1 upon r into y upon r j cap, plus lastly we will have what? 1 upon r z by r k cap. Fine. So we can write this on simplification as x I cap plus y j cap plus z k cap upon r square. So now this is your what? R bar. Fine. And this can be written as r into r. Okay, now we know that this r bar upon r is what? R cap. So this can be finally written as 1 upon r into r cap, because r bar upon r is what? Unit vector r cap, right? Okay, so we have proved our required quantity. Okay, so now let us go to the next example. We have to find the angle between surfaces x square plus y square plus z square is equal to 9 and x square plus y square minus z is equal to 3 at the point 2 minus 1 2. So first let us find the gradient of both these surfaces, right? Now we know that the formula of angle between two surfaces is given by cos theta is equals to gradient of first surface dot gradient of second surface upon magnitude of gradient of first surface into magnitude of gradient of second surface. So now let us find the gradient of the first surface. So gradient of phi 1 will be equals to del phi 1 upon del x I cap plus del phi 1 upon del y j cap plus del phi 1 upon del z k cap. So let us find the partial derivative of the first surface, that is phi 1 is equals to x square plus y square plus z square minus 9. So the answer of the partial derivative will be 2x, right, 2y and 2z. So now put the point 2 minus 1 2. So gradient of phi 1 and 2 minus 1 2 will be equals to, finally if I put x as 2, y as minus 1, z as 2. So answer will be 4 I cap minus 2 j cap plus 4 k cap, right? So this is your first answer. Now let us find the gradient of phi 2. The formula will be del phi 2 upon del x I cap plus del phi 2 upon del y j cap plus del phi 2 upon del z k cap. Okay. Now our phi 2 is what? X square plus y square minus z minus 3. So the derivative answer will be 2x I cap plus 2y j cap minus k cap, because derivative of this will be minus 1. Okay, now let us put the point 2 minus 1 2. So the gradient of phi 2 at this point will be 4 I cap. If I put minus 1 in this, minus 2 j cap minus k cap. So this is our next answer. Now let us find the value of cos theta. So cos theta is equals to 4 I cap minus 2 j cap plus 4 k cap dot 4 I cap minus 2 j cap minus k cap. This is dot product, right? Upon we have to write the magnitude of these both vectors. So here it will be square root of 16 plus 4 plus 60. Fine. Into this will be magnitude of this will be 16 plus 4 plus 1. Fine. So if I do the dot product now, answer will be 16 plus 4 minus 4 upon answer of this will be 32 plus 4, right? And square root. So square root of 36 will be 6 and here it will come square root 21. These two will get cancelled out and also we can cancel these two. So it will be finally 8 upon root 3 root 21. So the answer of theta will be cos inverse 8 upon 3 root 21. So this is the angle between the two surfaces. Okay. So now let us go to the next topic, that is directional derivative. So the definition of directional derivative of phi in the direction a bar. So this vector is a bar is given by gradient of phi dot a bar upon mod a bar, or you can write it as gradient of phi dot a cap. So whenever you want to find the directional derivative of any surface phi in the direction of a bar, it will be given by gradient of phi dot a cap. Okay. So now let us solve few examples. So we have to find the directional derivative of this surface at point 1 1 1 in the direction of the vector minus 1 0 and 3. So our a bar is what? Minus 1 0 3, or I can write this as minus 8 I cap plus 0 j cap plus 3 k cap. So our a cap will be a bar upon mod a bar, right? So it will be minus I cap plus 3 k cap upon square root of 1 plus 3 square, it will be 9, right? So final answer of a cap is minus I cap plus 3 k cap upon square root of 10. Now let us find the gradient of f. So formula will be del f by del x I cap plus del f by del y j cap plus del f by del z k cap. So let us write the derivative answers with respect to x, y and z. So if I do with respect to x, it will be 2xz, right? Minus, if I find the derivative with respect to x of this, so minus yz. Now do with respect to y. So answer will be 3y square z square minus xz. Fine. And the last answer of this will be x square then plus 2y cube z, right, minus xy. So if I put the value 1, 1 and 1, our answer of gradient of f at point 1, 1, 1 will be, if I put 1 over here, it will be 2 minus 1. So I can. Now if I put 1, 1, 1 over here, it will be 3 minus 1. So plus 2 j cap. And lastly, if I put 1, 1, 1 over here, it will be 1 plus 2 minus 1. So answer will be plus 2 k cap. Okay, so this is the answer of the gradient. So directional derivative answer will be gradient of f at point 111 dot our a cap. So let us put all these values. So I cap plus 2j cap plus 2k cap dot this, that is minus I cap plus 3k cap upon square root 10. So next let us do the dot product. So it will be minus 1, right? This will go to 0 plus 6 upon root 10 because here we don't have j cap. So final answer will be 5 upon root 10. Okay, so this is the answer of the directional derivative. Now let us solve one more example. You have to find the directional derivative of f of x comma y if f of x comma y is this and u is the unit vector given by angle theta is equals to pi by 6. So what is direction derivative of f at 1 comma 2 in the direction of u? So now we are not given our u bar, or we can say we are not given any direction. We are only given this angle pi by 6. So whenever you are given a unit normal vector, you can write your u bar as cos theta I cap plus sin theta j cap. Right? If you take the modulus of u or the length of u, it will be 1. You can see, right, from this. So now just put the angle theta. So u bar and will be equals to cos pi by 6 I cap plus sin pi by 6 j cap. So now we know the values of cos 30 and sin 30. So our u bar will be root 3 by 2 I cap plus 1 upon 2 j cap. So we have obtained our u bar. Now let us find the gradient of f. It will be del f by del x I cap plus del f by del y j cap. So now find the partial derivatives of answers with respect to x and y. Right? So if I do with respect to x, it will be 3x square minus 3y. And partial derivative of f with respect to y will be minus 3x plus 8y. Okay. Now let us put the point 1 comma 2 which is given over here. Right. So x is 1, y is 2. So if I put 1 over here, it will be 3 and 2 over here, 3 minus 6. So minus 3 I cap plus, it will be minus 3 plus 16, so 13 j cap. So the directional derivative answer will be gradient of f at 1 comma 2 dot u cap, right? Here our direction is in the direction of u bar. So minus 3 I cap plus 13 j cap dot u cap means u bar upon mod u bar. So dot root 3 by 2 I cap plus 1 upon 2 j cap. Mod u bar is 1. So we don't have to put that, right? Now just do the dot product. So last answer is minus 3 root 3 by 2 plus 13 by 2. So this is the answer of directional derivative. So I hope you have understood throughout the session. Thank you for watching.